Okay, so today's lesson, we're going to be plotting and analyzing swim data. So we're going to be putting it on a line plot. So this is kind of a review of some of the things that we've already done this year. So on Monday, the swim team coaches kept track to the nearest half mile of how many miles each team member swam. The following data were collected. So there was one swimmer that swam 2.5, another 2.5, a three and a half, a four, and so on. So we have to fill in the missing numbers on the horizontal axis of the line plot, then plot the data set. Okay, so we have our um, hashtag marks down here, our tag marks, where we're going to put our numbers. So we have to look at our numbers and decide what order we're going to put them in. And we know that when we put numbers on a line plot, we have to start with the smallest number and go up from there. So our smallest number here is what? 2.5. Okay, so 2.5 is going to be our first one. Now, what are we counting by? Okay, it says nearest half a mile, so we're counting by halves. So we have to make sure we're not even going to look at our numbers now when we put our numbers down here because we aren't going to just put the numbers here. We're going to put every number that is added a half each time because when we have a line plot, we can't skip numbers. So 2.5 plus 1/2 more would be 3, and then 3.5. Notice I'm not paying any attention to my numbers up above because sometimes that's where kids get into trouble. 4, 4.5, 5, and 5.5. And the reason kids get into trouble sometimes is they only put the numbers on here, and if there is something that is skipped, which I'm not sure if they did skip anything this time, but if there is anything that's skipped, then they'll have a blank at the end, and there shouldn't be. Everything should be filled in. Okay, so I'm going to look at my data, and how many 2.5s do I have? I have 1, 2, 3. So remember, in a line plot, I mark with X's, and I'm going to try to keep them about the same size. It's really hard to do when you're using a pen here. Now, how many 3s? I have 1, 2, 3 3s. So again, I want to try to keep my X's kind of across from each other so it's easier for me to compare when I'm done. How many 3.5s? I have 1, 2, 3.5s. How many 4s? 1, 2 4s. How many 4.5s? 1, 2, 3, 4, 4.5s. Whoa. Do not know why I did that. I do not know how to get rid of that, so it's going to stay there. How many 5s? I have 1, 2 5s. I guess I could have used an eraser there to get rid of that. Let me get rid of it with an eraser. If I can carefully. Okay, and then 5.5s, we have none. Okay, so the next thing that I always do is I count how many X's I have and count how many pieces of data I have to make sure that they match. So I have 3, 6, 8, 10, 14, 16. So I should have 16 numbers up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. If I did not have the same number, I would have to go back and see what I missed or see what my error was. Okay, So now I have to put my titles. So this up here is an explanation of what the graph is about. So what is our graph showing us? Well, if I look at keywords in my title here, I know it's a swim team, and I know what the coach is keeping track of is how many miles each team member swam. So I need to put that in. I could put how many miles each team member swam if I wanted to, but I'm going to try to make it a little bit shorter because I just want to give the information that is absolutely needed. So, and I can even use abbreviations. Number of miles swim team members swam. Now that turned out longer than I expected it to be, but I feel like that information is all important because you need to make sure people know that each one of these data points is one person. It's one team member. It's not the whole team doing it added together. So number of miles swim team members swam. Okay, and you could say that in different ways. Now down here you have to say what you measured in and what unit you used. So we measured half a mile. So I'm going to say miles and then in parentheses I could say to half a mile. Because miles is a measurement. It's not like we're measuring feet or yards or anything else. Miles is also a measurement. So I don't have to say they're swimming again because I said that up here. So all I have to do is say what I measured in and then what unit. So the units are half miles. Okay, so then I have some questions to answer. So I have to find the difference between the greatest and the least number of miles each person swam. So the most anybody swam was 5. Okay, so that's going to go down here. And then the least anybody swam was 2.5. Now remember, when it asks you a question like this, don't get tricked by the number of X's. So this one has more X's than anybody else, but that's not the greatest number that anybody swam. So 5 times 2.5. Now, this is one of those fraction problems where we have a half here and there's nothing up above. So it's like 5 and 0 halves minus 1 half. So you could probably do this in your head, but if you wanted to trade so that you would have some halves up above, you could take a whole and trade it for 2 halves because we know 2 halves makes a whole. So 4 and 2 halves would be the same as 5. So 2 halves minus 1 half would be 1 half, and then 4 minus 2 is 2. So 2 and 1 half is the difference between the team member that swam the most and the team member that swam the least. How many miles were swum altogether by those who swam 3.5 miles? So there were 2 people that swam 3.5 miles. So to do this, you would have to add 3.5 plus 3.5. And I know that 3 plus 3 is 6, and 1 half plus 1 half, oh, I'm supposed to put an unknown down here, sorry. 1 half plus 1 half is a whole, so 6 plus 1 whole would be 7 wholes, so 7 miles. How many miles were swum altogether by those who swam 2.5? So I have 3 people who swam 2.5. So I'm going to do 3 times 2.5. This is that whole number times a mixed number that we learned about the other day. So remember, I'm going to take my whole numbers times each other first. 3 times 2 is 6. And then my whole number times the fraction in the other problem. So 3 times 1/2 would be 3 halves. So 6 and 3 halves. Oh, that's supposed to be an unknown again. I'm not reading my directions very well. 3 halves is the same as 1.5. So 6 plus 1.5 would be 7.5 miles. Okay, how many miles were swum altogether by those who swam 4.5? So 4.5, there were 4 of them. So we would have 4 times 4.5. Again, whole number times a mixed number. So 4 times 4, I'm going to remember to put my unknown variable there. 4 times 4 is 16, and then 4 times 1/2 is 4 halves. So 16 and 4 halves miles, or 4 halves is the same as 2, so it would also be the same as 18 miles. How many miles were swum altogether by the 6 team members who swam the least amount of miles? So the 6 who swam the least would be down here at the end. So we had 2.5 and 3. So I already did 2.5. I know that was 7.5 miles. I have not done 3 yet. So 3 times 3 would be 9. So I would do 7.5 plus 9. And that would be 16.5. So 16.5 miles. So that's just a review of line plots, how to plot them, how to label them, and then how to go about answering data collection. So that's one of the 4th grade standards. So thanks for watching and practicing.